we use double integrals to find the area of a surface. The area of the surface with equation z equals to f of x and y. Note that you have a domain, so we are taking all of these in the domain, from the domain of the function, with the condition that the partial derivatives, they are all continuous. Fx and Fy are continuous. Is defined as AS, the area of the surface, which has double integral over region d of the radical. You're going to take the derivative with respect to x, raise it to the second. You're going to take the derivative with respect to y, raise it to the second, plus 1 dA. Very good. A quick example. In this example, question says, find the surface area or area of the surface of the part of the surface z equals to x squared plus 2y that lies above the triangular region T in xy plane with vertices 0 and 0, 1 and 0, 1 and 1. Very good. So our goal is to find the area of the surface. You have a surface and you want to know what is the area of that surface. Well, we have a nice formula. We know how to follow the formula. Taking the partial derivatives are not very difficult. But we need to identify the region, what the base look like. We are restricting this surface to the following region. So what's the base look like? Let's graph this guy. In xy plane, we have 0, 0, 1 and 0, 1 and 1. So this is our triangular region that we're dealing with. So as we all know, this is y equals to x. This is just 0 and you have 1 here. Well, so it's not very difficult to see that x is bounded between 0 and 1 and y is bounded between 0 and x. Very good. So let's set up the integral of the surface area is the integral. So our x is bounded between 0 and 1. The fixed values are associated to the outer integral. And the y is bounded between 0 and x. Here you have the radical. The partial derivative with respect to x is 2x squared plus partial derivative with respect to y is 2 squared plus 1 dA. Very good. So this becomes 0 to 1, 0 to x, integral for x squared plus 5 dA. So let's start taking the integral. You're taking the integral with respect to y and then with respect to x. this guy has nothing to do with y. So you can just write it as the integral 0 to 1 square root of 4x squared plus 5 and the integral of 0 to x dy, and then take the integral with respect to x. So this integral becomes integral of y, and y ranges between 0 to x. So this is nothing but 0 to 1 x times square root of 4x squared plus 5 dx. You can use u sub. U is 4x squared plus 5. Du is 8x dx. So let us multiply by 8, divide by 8. And this guy becomes 1 over 8, the integral of square root of u du, or 1 over 8. Here you have a half, so we get 3 halves. 2/3 of 4x squared plus 5 to 3 over 2, and x ranges between 0 to 1. Let us substitute these. What do we have? We have 1 over 12. If you plug in 1, you get 9 to 3 halves and minus 5 to 3 halves. So if you use a calculator, or just leave it as radical, here you get 1 over 12. This is 3 to the second. You get 3 to the third minus, here you have 5 square root of 5, or just 27 minus 5 square root of 5 divided by 12. So this is the area of the surface. If you use a calculator, you can find an approximation for the area of the surface as well.